Here we start NCEA level 2, normal distributions. Normal distribution looks like that, lovely little curve, and the main thing to realise is that the area under the graph represents the probability of the event occurring in that range. That's going to matter because our calculator uses area as well as probability. The normal distribution has the following features. It's got a lovely bell shape, and those words are something you should remember. Most importantly, the mean, the median and the mode are all the same value in the middle, and that follows, in fact, from the fact that it is symmetrical. This side of the graph is exactly the same as this side of the graph, so of course everything is in the middle. And it has very few extreme values. That's really important. Out here, the values tend to tail off. If you have a lot of outliers, a lot of very strong values on either end, then it may well not be a normal distribution. And a normal distribution can be described with two parameters. Don't worry about the word parameter, it's just a word for something that describes a situation like this. The mean, we use the Greek letter mu, which is the m, which is the center of the curve, and the standard deviation sigma, we use the Greek letter s, which is how spread it is. The area under the graph represents probability, as we said before. One standard deviation either side, the shaded area, is 68% approximately of the values. Two standard deviations covers 95% of the values, and three standard deviations covers 99% of the values. That is, almost every value inside a normal distribution is within 3 standard deviations of the mean. For those of you who are technically minded, and this is not hugely important to achieve merit, the point of inflection where the curve turns from being increasingly steep to less steep is at 1 standard deviation. Now when we take a sample, even if it is a really accurate normal distribution, we always have some variation from the ideal. That is, sample variation will always happen, and we don't need to worry too much about it. Just because this graph doesn't look like a perfect fit doesn't mean the distribution isn't normal. It may be, it may not be, but we don't really have enough information to tell. As the sample size increases, deviations will decrease, and our fit now is much better. We have a lot more confidence that that fit, or that histogram, is for a normal distribution. Sometimes they can look a little bit asymmetric, like this one here, but in fact, when you actually try to sketch in the curve, you'll find that in fact it fits very well indeed. That's because the mean, which is in the center here, is not exactly in the middle of the bars. So there's a bit of asymmetry apparently caused by that, but in fact the actual distribution is pretty much normal. Always regard the sketch is very important, and what you try and do is try to get your graph to go through the centers of each of the bars, and if you can do that, ignoring the odd variation, then you've probably got a normal distribution if it looks like a bell. If you're asked in a question whether a distribution is normal or not, these are the things you should write down and talk about. Is it symmetrical, more or less? Is it bell-shaped? How many extreme values are there? Because lots of extreme values are not consistent with a normal distribution. And consider the sample size. A small sample size is very hard to tell whether it's normal because the sample variation tends to take control. And that's basically what you need to know when discussing whether a distribution is normal or not.